Bismillahirrahmanirrahim. In this video we will study confidence interval for population mean mu when sigma is unknown and n is less than equal to 30. N is the sample size, sigma is the population standard deviation. The condition is same as the previous topic. In previous topic you have done testing of hypothesis for population mean mu when sigma is unknown and sample size less than equal to 30. So what is the difference in testing of hypothesis and confidence interval? This is the important thing. In testing of hypothesis, we test either the population mean or null hypothesis is true or false. We test the population mean with the help of sample size. Mu is the parametric value. Parameter means population value, population mean, population standard deviation, etc. is called parameter. Okay. And x bar, sample mean, sample standard deviation is called statistic. So in confidence interval we will find the lower and upper value of the population mean. In testing of hypothesis, we test either the population mean is true or false with the help of sample statistics, sample mean, sample data. In confidence interval, we find the lower and upper value of the parametric value, parameter, mean, standard deviation, etc. This is the difference. Okay. So if x bar and s are the mean and standard deviation of a random sample of size n less than equal to 30 from an approximate normal population with unknown variance sigma square. This is the important condition. A 1 minus alpha into 100% confidence interval for mu is given by. This is the formula used for the testing of hypothesis for population mean. Mu, for this condition sigma is unknown and sample size is small, less than equal to 30. You have used same condition in testing of hypothesis. We test either the population mean is same as the standard value, given value with the help of sample data. In confidence interval, we find the lower and upper value, lower and upper acceptable value with property of error. So all the terms are same as the formula of the t-test. X bar sample mean as sample standard deviation and sample size. T alpha upon 2 comma mu, mu the degree of freedom, alpha is the level of significance, and with the help of level of significance, alpha and degree of freedom, we find the table value. We will find the table value from table. I have already explained in testing of hypothesis, and substitute in this formula you will obtain the lower value of the population mean, lower acceptable value of the population mean. And right hand side is same as left hand side, but here left hand side we use negative sign, right hand side we use the positive sign. So all the terms are same as the left hand side. You will obtain after substituting the value of x bar, table value, sample standard deviation, sample size, upper value of the population mean. So if the level of significance alpha is the 5%, alpha upon 2 will be 0.025. I have already explained in testing of hypothesis, total area under the curve is the 100%. This 0.025 plus 0.025 equal to 5%, and this area is the 95%. This area is called confidence interval. 1 minus alpha, total probability is 1 minus alpha upon 2 plus alpha upon 2 alpha into 100% confidence interval of the total 100% confidence interval. So this area less than this area and upper than this area is called critical region, rejected region, and this green area is called acceptance region, accepted area, and represented by 1 minus alpha, because the total probability under the curve is 1. So if this plus this is equal to alpha, this will be equal to 1 minus alpha. So 1 minus alpha is called confidence interval. Okay, so this is the formula for confidence interval. This is a diagram, and with the help of this you will obtain the lower and upper value. Lower and upper acceptable value is also called confidence interval, confidence limit, control limit, etc. Okay, so now we will solve the numerical. You have solved this question in testing of hypothesis. The content of 7 similar container of sulfuric acid are given 9.8, 10.2 and so on. Later find a 95% confidence interval for the mean content of all such container. This indicates the question of the confidence interval for the mean. Assuming the approximate normal distribution for container contents. So 7 similar containers, n is equal to 7, degree of freedom mu will be equal to n minus 1 6. From this data you will obtain x bar and s. This is the x bar is here, x bar mean 10, s standard deviation. 95% confidence interval means 95% confidence interval means 1 minus alpha. This is the 1 minus alpha is equal to 95% means 0.95. So 1 minus alpha 0.95, alpha will be equal to 0.05. For this value divided by 2, we will obtain alpha upon 2 0.025, and with the help of 0.025 with degree of freedom 6, you will obtain this table value from T table. Why we are using here T table or T statistics, T test? Because question is confidence interval for mean. For mean we use T test and Z test, and when we use the T test, when sigma is unknown and sample size is small. So there is no sigma is not given, and sample size is only 7. Substitute x bar 10 is table value, s is the standard deviation divided by square root of n 7. Same as right hand side, substitute all values, simplify, you will obtain the lower and upper acceptable value or confidence interval. So first we will calculate this term and then subtract from 10. If you first subtract from 10 this value and then multiply by this, this will be completely wrong. So first calculate this term, then subtract from mean. Here first calculate this term, then add in mean x bar. So what is the conclusion? We are 95% confident that, question is find the 95% confidence interval. So we are 95% confident that population mean of content of all container will be lies between this value and this value. So we are 95% confident that the population mean of the total containers of the population will be equal to 9.74 liters and 10.26 liters. Okay. Now homework for confidence interval, chapter number 9, page number 263 and question number 11 and 12. This is chapter number, page number and question number 11 and 12. Allah Hafiz.